Good morning. Today I'll be discussing the combination 2 under the concepts of fundamentals of principles of counting. So let us see the example 1. In the example 1, they're told that a party is attended by n person. If each person in the party shakes hands with all the other persons in the party, find the number of handshakes. So there are n persons. There are n persons. So let us take A and B are the two people. A and B are the two people. Over here, let us assume that there are two people, A and B. If each person in the party shakes hands with all the others in the party. Now let us assume that A and B shakes hands. So A shakes hands with B, similarly B will shake. So how many people are involved while shaking the hands? There are two persons. There are two people involved over here. If each person in the party, so there are n person. If n persons shakes hands, then there are two particular persons who will be shaking. So with all the others in the party. So find the number of handshakes. So the number of handshakes will be NC2. Why 2? Since two people are involved while shaking the hands. So here the solution is each handshake is determined by exactly two persons. Each handshake is determined by exactly two persons. Therefore, if each person shakes hands with all the other person, therefore, if each person shakes hands with all other person, with all the other persons, then the total number of handshakes, is equal to the number of combination of two persons. That can be selected from the n persons. That can be selected from n persons. So the solution is NC2, that is nothing but n factorial divided by n minus 2 whole factorial into 2 factorial. So if you just solve, it will be n into n minus 1 into n minus 2 factorial divided by n minus 2 factorial into 2 factorial. So this would get cancelled and it is nothing but half into n minus 1. So this is the solution for the example 1. Example 2, there are n married couples attending a party. So the couples are nothing but n. This is n is couple. There are n married couples attending a party. Each person shakes hands with every person other than his or her spouse. That means in n couple, you have to find the number of combination where he shakes hands with the rest all of the people other than his wife or husband. So find the total number of handshakes. Here, if n is a couple, then the total number of people is 2n. Total number of people is 2n. So you know that total combination is 2n C2. Why it is 2n C2? Since total number of people is couple involves two people, so it is 2n C2. Why? Because two people. This is the total number of combination. I should do minus n over here. For why I should do the minus n? Because for example, if it was, I need to separate this particular n, since they shouldn't shake with their own spouse. They should not shake hands with their own his or spouse. That means they should not shake with a pair of husband or wife, their husband or wife. So it is 2nc2 minus n. So over here 2n is total number of people, handshaking involves 2, minus n is nothing but when they shake hands with their couple or with their spouse. So the solution you can write is the number of person The number of persons at the party is 2n. The number of persons at the party is 2n. These 2n persons fall into combination of 2n comma n pairs out of which n pairs are married couples. Pairs out of which n pairs are married couples. Out of which n pairs are married couples. Thus the number of pairs who are not married couples, is combination of 2n comma 2. Handshakes is 2n comma 2 minus n. Why this n? This n is nothing but that they shouldn't shake their hands with their own spouse. So it will be, the factorial will be 2n factorial divided by 2n whole factorial divided by 2n minus 2 factorial into 2 factorial minus n. So this would be 2n into 2n minus 1, 2n minus 2 factorial divided by 2n minus 2 whole factorial into 2 factorial. So this and this gets cancelled, and here minus n, and this also will get cancelled. So it would be 2n into, you can keep it as 2n, or else 2n n into 2n minus 1 minus n into 2n minus 1 minus n. So this would be nothing but 2n square minus n minus n. So that is nothing but 2n square minus 2n. So if we take 2n common, it would be n minus 1. So this is the final results. So it is 2n into n minus 1. This is the final result. So this is regarding the example 2. So example 3 is, find how many distinct 4-digit integers one can make from the digits 1, 3, 3, 7, 7, 8. So you have to find a 4-digit integer you're supposed to make. You're supposed to make 4-digit integers by using these integers. So the 4-digit integers that can be formed using the given digits fall into 3 categories. The first category is, you can have either both, two identical, that is 3377. Other format is, you can have 2 identical and 2 different. That means 2 identical ones you can take and 2 different. Third condition is, all 4 are different. So these are the 3 possibilities you will be getting while solving this particular problem. That is, you have to find a 4-digit number. So either the case can be 3377. The other case might be, you're taking 33 with 2 different integers, and the last one is all 4 are different. So let us solve the first one, the first case. That is, out of these 3 categories, let us solve the first case. 2 of the 4 digits are identical and other 2 are identical. 2 of the 4 digits are identical, and another 2 are identical, So when it comes with the 4 digits, 2 of the 4 digits are identical and another 2 are identical, then we are supposed to do the combination is, there occurs one combination under this category. There occurs one combination under this category. one combination under this category consisting of two threes and two sevens. Okay. So the number of permutation in this combination is, see, whenever it comes with the distinct terms, we are applying the term permutation concept. So just remember, whenever it comes the distinct terms, we are applying the concept of permutation. So the number of permutation of this concept, the number of permutation in this combination is 4 factorial. Why 4? Because we have to find 4-digit number. So two of the 4-digit are identical and another 2 are identical. That means what? Combination is 3377. So repetition should be divided. So 2 factorial by 2 factorial. So you'll get it as 4 into 3 into 2 divided by 2 factorial is this, and this gets cancel. Again 2 factorial, 2 ones are 2. So totally you will get 6. So this 6 is nothing but the possible when you have two identical integers and another two identical integers. So you can just write here 3377 7733. Other than that, formation is like 7337 3773, or else it may be like 3 or 3. Other possibilities might be like 3 7. So one possibility is done over here. 3377 7733 7337. Two more formations we want, so that would be like 7 3 7 3 3 7 3 7. So these are the 6 combinations when we get two of the 4 digits are identical and another 2 are identical. So why we are doing in terms of permutation? Because he has told find how many distinct 4-digit integers one can make from the digit this. So the cases would be like these 6. We have 6 integers. Out of that we are using 4 integers to form. So I took 2 of the 4 digits where 2 are identical, other 2 are identical. So 4 factorial divided by 2 factorial and 2 factorial, you got 6 ways. The second one, let us do in the next new page. The second condition I told is 2 of the 4 digits are identical. 2 of the 4 digits are identical. 2 of the 4 digits are identical, and another 2 are distinct, and another 2 are distinct. So here, when you take 2 of them are identical, so for example, let us take 3 and 3, 3 and 3, and let us take 4, let us take 3 3 and 1 8. So this is one form, 2 identical. I just gave an example, 3 3 1 8. For this combination, how many ways we can get is 4 factorial divided by 4 factorial. So 2 factorial is of this repetition, and 1 factorial and 1 factorial. So this will give you 12 ways. But see, I just took 3 3 1 8. For this there are 12 ways of arrangements. But in case if you would have taken 7 7 1 8, 7 7, see, I took 2 3 and 1 8. In case if I would have taken 7 7 1 8, or else like 3 3 1 7, or else like 3 3 8 7, 7 7 1 3, 7 7 3 8, 7 7 1 3, 7 7. So totally how many ways are there? This is for the one way I've told. So totally how many ways we have? So there actually occurs 6 combination of this type, like 2 identical numbers, 3 3 7 7 3 3, with the combination of all this. So this should be multiplied with this 6. So here you can write there occur 6 combinations of such type. 6 combinations of such type means 2 identical and another 2 are distinct of under this category. So the result will be nothing but 12 into 6 whatever this same into 6, so that is nothing but the 72. So the third one, last one is all 4 are distinct. All 4 are distinct means that is we can have only 7, 3 and 1, 8. So possible is only one arrangement. For this you have to find. So all the 4 digits are distinct. All the 4 digits are distinct. So for this you can find there can occur only one combination, as you know. So it is 4 factorial divided by 1 of 3, 1 of 7, 1 of 1 and 1 of 8. So this will give you 24. So therefore the total number of integers is precisely the total number of permutations in all the categories mentioned above. So that is the number is addition of all what we got. The number is, for initially we got 6, then we got 72 plus 24. So this would be 102. So this is the result. This is regarding the example 3. So here example 4, find the number of arrangements of all the letters in Tallahassee. How many of these arrangements have no adjacent A? So this is nothing but the permutation itself, and here how many of these arrangements have no adjacent A's, they are mentioned. So find the number of arrangements of all the letters in this. Let us do in a new page. Okay, so the find the number of all the arrangement of this word. So that is TALLAHASSE is the letter. So this is similar to how we have done the permutation. Question is find the number of arrangements of all the letters in Tallahassee. So you know that whenever it tells the arrangements, we will see how many letters have been repeated. Distinct we are going to form. So totally count how many letters are there. So the number of letters in the given word is the number of letters in the given word is 11, out of which 3 are A's, 2 each of L, S, E, and 1 each of T and H. So therefore the number of arrangement of the letters, the number of arrangements of the letter in the given word is 11 factorial divided by repeated of those letters 3, 2 of L, 2 of S, 2 factorial of E, and 1 of T and 1 of H. So this was a simple because we had already solved. So this was clear. So their first question was find the number of arrangements of all the letters in the word Tallahassee. Next sub question is how many of these arrangements have no adjacent A's. Second sub question is, this was first. Second is how many of these arrangements have no adjacent A. So if it is no adjacent A, what we have to do, meaning is what? A, and there are 3 A's, right? They should never be A together. Meaning is they should never be A together. So what we can do is, if we disregard A, then disregard A means if we remove A, then how many letters will be there? So 11 minus 3, it is 8 factorial divided by 2 factorial, 2 factorial, 2 factorial, and 1 factorial and 1 factorial. So this would give you 504 ways. So this is arrangement of all the letters except A. So in each of these, so in case if I just want, I'll write over here. I'll write over here. If I just want to write T L except A, right? T L L H S S E and E. Okay, T double L H double S double E. So it is 1 2 3 4 5 6 7 8. So now this is what I just found, the arrangement of these letters. Now they should not be adjacent A. That means I can have A over here, or 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 here. This is the right place where A can have. So how many places are there for A actually? So 1 2 3 4 5 6 7 8 9. So there are 9 places for A where 9 A's are not together. Where A's are not together. How many A's are there? Out of that, how many A's? 9 positions are there. How many combination is possible? So it is 9C3. Since we have 3 A's, it is 9C3. So it is happening simultaneously. We found the arrangement of these letters as this. Now remaining is nothing but regarding the A. So this should be multiplied with the combination of this. So here you can write, in each of these arrangements, there are 9 possible locations. There are 9 possible locations. You can write this figure and show there are 9 possible locations for 3 A's. For 3 A's, these locations can be chosen. These locations can be chosen in combination of 9,3 ways. Therefore, the number of arrangements having no adjacent A, is this, that is 5040, this into 9C3. So that would give you 5040 into 9 factorial divided by 9 minus 3 is 6 factorial into 3 factorial. So that is nothing but 5040 into 84. So that would give you 4,23360 ways. So this is regarding the example 4. So here the number of letters in the given word is 11. First, this was clear. No adjacent A's was my second criteria. So I just removed the A's. Except A's, I did the arrangement of these letters. I got 8C, this factorial ways. And if no adjacent A's means obviously A should be here, 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 in between these letters. So there are 9 locations, but I have 3 A's, so 9C3. Why I multiplied with this? Because it is happening simultaneously. So it is a product rule. So 5040 into 9C3, I got so many ways. So this is regarding the example 4. Next, let us go to the example 5. In the example 5, let us solve the first one. Prove the following identities. So the first one is, prove that C of n comma r minus 1 plus C of n comma r is equal to C of n plus 1 comma r. Okay, so this we have to prove. This is equal to this. So let us take left hand side and solve. So C of n comma r minus 1 plus C of n comma r. Apply the formula. So it would be nothing but n factorial divided by n minus r minus 1 within the bracket n minus r minus 1 factorial into r minus 1 factorial plus, for this it is directly formula n factorial divided by n minus r factorial into r factorial. So here when you take the minus inside, it would be n minus r plus 1 factorial, because minus r minus minus will be plus, and here into r minus 1 factorial, and here it would be n factorial divided by n minus r whole factorial into r factorial. Okay, so this is over here. So now what I'll do is I can take n common, n factorial, I'll take it common. Okay, and then I'll try to take r minus 1 factorial common, as well as n minus r r whole factorial out. Now when I took this out, what it would be is, here it would be 1 by n minus r minus plus 1. Okay, and here it would be 1 plus r. 1 by r. How you got it, I'll tell you. Here I took r minus 1 factorial out. So here when I take r minus 1 factorial out, it is nothing but r into r minus 1 factorial. Here r minus 1 is already there. I took this out, r minus 1 factorial out. Here r factorial is there. So r factorial is nothing but r into r minus 1 whole factorial. So remaining is r. So that is over here. So I took r. Next I took n minus r. This I have taken. So n minus r factorial. Here we have n minus r plus 1 factorial. So if you do next step of this, it would be n minus r plus 1 into n minus r plus 1 minus 1 factorial. So this and this gets cancelled. So that is nothing but n minus r. So we can take n minus r factorial, n minus r factorial. So I took n minus r factorial. Left out will be n minus r plus 1. Now what we can do is, I'll do the continuation over here. Now what I can do is, I can take the LCM within inside. So here it would be n factorial divided by r minus 1 factorial into n minus r factorial. Here if I take LCM, it would be r plus n minus r plus 1 divided by n minus r plus 1 into r. Okay, so this and this gets cancelled. So it would be nothing but n factorial divided by r minus 1 whole factorial into n minus r whole factorial into n plus 1 divided by r into n minus r plus 1. Okay, so you got it as n plus 1 r into n minus r plus 1. So how can we get this as? This we can write, numerator we can write nothing but n plus 1 into n is nothing but n plus 1 factorial, and this r into r minus 1 I can write it as r factorial. This and this I can write it as r factorial, and n minus r as well as n minus r plus 1 can be written as n minus r plus 1 whole factorial. So you got it as n plus 1 n minus r plus whole factorial. So this is nothing but combination of n plus 1 comma r. If you just apply formula, it would be n plus 1 whole factorial, n plus 1 minus r. So you got n plus n minus r and r factorial. So here we proved LHS is equal to RHS. In that again we had a sub question of second one. So that is this question. So let me solve in again next page. So it would be, the second question we had to prove is combination of m comma 2 plus combination of n comma 2 is equal to combination of m plus n comma 2 minus mn. So here we have m comma 2 plus combination of n comma 2 is equal to combination of m plus n comma 2 minus mn. So what we get over here is, let us solve again the left hand side. So when I solve the left LHS, I'll solve. So when I solve LHS, what I'll get is m factorial divided by m minus 2 whole factorial into 2. That is 2 factorial is 2 itself. So I just wrote 2 into plus n factorial by n minus 2 factorial into 2. Okay, you can write 2 factorial itself, fine. So here if I just try to solve, it would be nothing but m into m minus 1 and m minus 2 factorial will get cancelled. M minus 2 factorial divided by m minus 2 factorial, 2 factorial. So this and this get cancelled, plus n into n minus 1 into n minus 2 factorial divided by n minus 2 factorial into 2 factorial. So this and this gets cancelled. So it would be nothing but m into m minus 1 divided by 2 factorial plus n into n minus 1 divided by 2 factorial. Okay, so it would be m into m minus 1 divided by 2 factorial, or n into n minus 1. So if we try to solve this, I can take half out. I can take half out. Half in the sense 2 factorial is nothing but this itself. And if I just multiply this, it would be m square minus m plus n square minus n. So this I'll get it, m square plus n square, m square plus n square minus m plus n. So this, right, compare over here. Further, if I want to solve, I should get minus mn separately, and here in this, check the right hand side. Further, if I, this would be nothing but half into m square plus n square, okay, minus m minus n. Okay, so here somewhere I want to get mn, and here somewhere I want to get m plus 1 comma 2. So what I'll do is, this form I want to get it, so I'll solve over here. I will rewrite it as half, and I'll take just m plus n. I'll write it as m plus n and m plus n minus 1, and this minus mn I want. I'll tell what I'm doing. I want minus mn, I wrote as it is. This I wrote m plus n, or next term m plus n minus 1. Okay, this itself I've just written there, m plus n. Next term is m plus n minus 1 and minus m. Now you just try to solve this. Try to solve this and check this also whether you'll get it or not. So this is just a trial. So then you can replace over there. So what I'll do is, here in one section I'll just solve. Minus mn I want. This further I can get only in this form. Further if I solve also, I'm not going to get anything. I want to make this to equivalent to this. So minus mn you write as it is. M plus n you write. M plus n you write, and write the next term. What is the next term? M plus n minus 1. Okay, let it be m plus n and m plus n minus 1. So if you solve, what you'll get it as? You'll get it as m square. You'll get it as m square. Multiply all with this. You'll get m with this and with this with this. So you'll get plus mn minus n. Again multiply with n square. It will be nm plus n square minus n. And let this be here as it is, and this is minus mn you add. Minus mn. So this is actually okay, you'll get it as this entirely, and this minus mn. So what is happening over here? You check, you have m square plus n square, and you have, this is minus m, sorry, and you have minus m minus n. Then you have 2mn minus n, you get 2mn. Okay, 2mn minus mn. So when you compare over here, it would be nothing but, if you just replace, half is over here. So when you multiply here, when you multiply this plus 2mn, so this gets cancelled, and that mn and this mn gets cancelled. Left out is just this term itself. So what I'll be doing is, here in this continuation step itself, I'll just write half, and I'll replace with this term. So that would be nothing but half into m plus n into m plus n minus 1 minus mn. So same thing I wrote. So if you just see over, if you want to check, you can check here. Half into, it would be nothing but m square plus mn minus m plus n square nm plus n square minus n, and this minus mn. Okay, this is just for your understanding. This is not required to write, because you will get back to this itself. Continuation is, I'm just trying to make you understand. So again you will write half. So this would be m square plus n square plus minus m minus n plus 2mn is there, okay, and minus mn is there. So what I'll do is, I'll keep half over here, and this m square I'll write as it is, n square I'll write as it is, minus m I'll write as it is, minus n I'll write it as it is, and this half I'll multiply for this. So that will be what? Plus mn minus mn. So this and this gets cancelled. Finally, it resolves to this itself. Check here. Finally, this resolves to this itself. So that's why instead of this, I can write back tracing. Instead of this, I can write it in this form. I'm telling this form. So this is the form. Okay. So now from this step, continuation is over here. This I just made you to understand how this is equal to this I have written. I made you to understand over here. So it is, you got half. This is one section. You got half into m plus 1 and m plus n minus 1. So mn is already there. Mn is already there. Okay. So mn is already there. So how can I write this in terms of factorial? Okay. So from this step it is continuation. So you can write it as m plus n whole factorial, because m plus n whole factorial, half is over here itself, divided by half, divided by m plus n minus 2 whole factorial. What is the meaning? M plus n whole factorial means here you should get only these two terms. So what is m plus n? What is the meaning of this statement is m plus n whole into m plus n minus 1 into m plus n minus 2 factorial, and here also m plus n minus 2 factorial, both gets cancelled. Back you'll get this itself. So I wrote it in this form, that's it. Minus mn, minus mn. Now check here, what is this again? It is nothing but m plus n whole factorial divided by m plus n minus 2 factorial, and 2 factorial is over here. So what you got is nothing but combination of m plus n comma 2 minus mn. So left hand side is equal to right hand side. So this is regarding the example, in this example 5, second problem. Next is last problem is regarding prove the identity. This is equal to this. This is equal to this. So what I'll do is I'll just take the LHS again. Let us solve in the new page. So they have told that C of n r, n comma r dot C of r k is equal to C of n comma k into C of n minus k comma r minus k. For n is greater than or equal to r, that is equal to k. Okay. So let us solve just left hand side of this. So C of n comma r into C of rk I'll solve. Okay. So it would be n factorial divided by formula itself, n minus r whole factorial into r factorial, and again here it would be r factorial divided by r minus k whole factorial into k factorial. Further, what I'll be doing over here is I'll just cancel r and r over here. Okay, I'll just cancel r factorial and r factorial. I'll write n factorial over here. See the right hand side, I required one is nk, another one is this factorial. Okay, so have just see here, if it is n, this formula, it is just n factorial divided by n minus k factorial into k factorial. So I need k factorial over here. Let me write k over here, and here I will be I don't have anything, let it be 1, and divided it is n minus r factorial into r minus k factorial. Why I wrote r minus k factorial? Because second term, this r is here also this is separate, and I don't know what is here I just wrote over there. Now you see here what is missing to form nck, that is nothing but n factorial divided by k factorial. I wrote n minus k whole factorial is missing, and even over here in this, if this has to be formed in this form, n minus k whole factorial is missing in the numerator. So what I'll do is I'll multiply and divide by, I'll write over here, I'll multiply and divide it by n minus k whole factorial. So where I need n minus k whole factorial over here, n minus k whole factorial into k factorial, I divided, again multiply, that means I want in numerator n minus k factorial. So I got this form itself, n minus k factorial. Here let us check, it is n minus r factorial into r minus k factorial. Check this, this is in the form of what? It is nothing but C of n comma k itself. We got the one part. Here let us try to resolve. If it is, this is n minus k, n minus k factorial, and this is n and this is r. Okay, this is n and this is r. So let us try to do n minus r of that. So that would be nothing but n minus k. This is n, right? So n minus k minus r minus k, r minus k. So n minus k minus of r minus k. So it would be nothing but n minus k minus of r minus k is one section of this factorial into r minus k whole factorial. So what is this now? Minus and minus k, and this would be plus k. So it is c of n comma k into n minus k factorial divided by n minus k as it is I wrote minus r plus k factorial into r minus k whole factorial. So this would be nothing but c of n comma k into n minus k whole factorial divided by n minus r whole factorial into r minus k whole factorial. This is the required. So now you check what it is. It is in the form of, again, n and n. Here you got n minus r. So that you check over here, we got r over here. Backtrace this particular n minus k divided by n minus r into r minus k whole factorial. So you got this section itself. If you check, you got this particular section. So that is nothing but c of n comma k into c of n minus k comma r minus k. So left hand side is equal to right hand side. So this is regarding the example 6.